Hello and welcome everyone. Myself, Ashwita Salian from Department of MCA. On behalf of Visit, I would like to welcome each one of you for today's session, which is organized by WeReach 2022. WeReach is an alumni engagement initiative. Today we have Mr. Mehul Tuteja with us. He's working as a smart contract engineer at Spirax firm. He has completed his MCA from Visit in 2020. Mr. Mehul has a great understanding of the blockchain technology, and today he will be speaking on what is blockchain, its career opportunities, and scope. I'd like to welcome Mr. Mehul and take it over from here. Over to you, sir.
Thank you, Ashwita, for a warm welcome. And it was indeed a very emotional beginning of the session with the video. And whoever has made the video, whoever has directed, edited, shot, has been a great job. You won't realize because you are studying over there, but it's been almost 3 years that I've graduated from Visit, and I really miss college. And by seeing this video, it got me emotional. But not taking much of your time on this. So welcome. Thank you for taking out your time on a Saturday. And I would try to make it as interesting as knowledgeable as possible, so that your time you have taken out on a Saturday is worth, and you get to learn something, and it helps you in a better way for your future. So I'll quickly share my screen so that I have a PPT. I have a presentation prepared for you, so that I don't lose track of time, and I don't lose track of what I want to cover, and I don't miss anything. All right, I'll begin. So, is my screen visible? Hello?
Yes, Mehul, it is.
Yes. Okay, thank you. Okay, so this session is primarily on what is blockchain, because blockchain is a technology which has revolutionized everything, but then everybody doesn't know about it. There's a lot of need for awareness about blockchain. And on a side note, as you all are students, and I was also a student 3 years back, so you might be interested in knowing the career opportunities and scope, and you might have to do some research. So I'll tell you about what are the topics in which we still need some research, we still need innovations, and we still need more people to join and bring in their ideas by using their brain. So a little bit about myself. Who am I and why should you listen to me? So my background, I was born in Rohtak, a small city in Haryana, and then my childhood was in Delhi, and my young age was in Mumbai. Education, I've completed my BCA from Bharati Vidyapeeth, and I've completed my MCA from Vesit, Chembur, and after that, after completing my MCA, I joined BNP Paribas. It was through campus placement only, but I was there as a tester. I was selected as a software developer, but then due to some role and availability issues, I was shifted to testing. But then it was my first job, and in 2020, COVID came, so I didn't have any other option rather than continuing that. So I worked over there for 2 years almost, and before leaving BNP, I got interested about blockchain. I took out a loan and put all my money in blockchain. I invested in cryptocurrencies, and I made some money. And but then I got to know that we can also build a career in blockchain, not just money. We can also build a career in blockchain. So I started following some roadmaps of some random YouTubers. I started learning about blockchain on YouTube and various other sources. I got involved into communities, and after that, in December 2021, I got my first job into blockchain, which was with Rapid Innovation, and over there I was a blockchain developer, but I was working on different projects one after the other. And I worked there for 6 months. It's a great company, and they have about 250 people, and they're building some crazy things, but it was not aligned with what I wanted to do. So I got shifted. I changed my company again, and recently, 2 months back, I joined Sperax as a smart contract engineer. So I don't work on multiple products. I work on a single product. We have a stable coin of our own. The stable coin is USDS. So basically, a stable coin in a crypto world is a cryptocurrency which is pegged to a stable coin, which is USD. So when I say USDS, its value will always be $1, will always be equivalent to one US dollar in fiat currency. So if anything of this is a bit overwhelming for you, please make a note of your doubts and we'll clear it. We have a Q&A session towards the end of the we have a Q&A round for towards the end of the session. And I've also put in a lot of hours into study. It's probably more than 1000 hours. So I know a little bit more than you about blockchain, and I earn a lot of money. That's what everybody wants to do. So it's not just job with which you can earn money, but it's also you can do arbitrage trading. You can buy flash loans, and you can do a lot of other things with blockchain to earn money basically. And you don't need anything. You don't need to be above 18. You don't need to have a PAN card. You don't need to have a bank account to do that. You just need an internet and laptop. That's it. uh, and I'm hiring. Yes, actually I have a couple of ideas for which I'm working on, and I'll obviously nothing can be done on my own, so I need more hands to help. So I'm hiring. You can get in touch if you are ready to work. You can get in touch with uh, the coordinator of this session, Ashwita, or maybe Indira ma'am, and maybe we can connect later. So these are some of the topics which we'll cover today. So what is blockchain, how blockchain changes everything, are we too late to join this, and some prerequisites that you need to have before joining blockchain. Then there's a 3-step process which is very easy and simplified. You have to know, you have to learn, and then you have to implement. So these are some of the things which is very important if you want to get into blockchain. Like, what is the difference between centralized and decentralized? What is distributed? What is cryptocurrency? Web3, crypto exchange versus crypto swap, NFT, dApps, which is decentralized applications, DeFi, and metaverse. These are some of the concepts which you need to learn, which is basic, very basic to start with. Then if we go on an advanced level, we have token standards, we have factory contracts, we have a lot of other things. I don't want to overwhelm you with those things now. Then what are the career options in blockchain, and then how to get your first job in blockchain. Then what is the scope and research opportunities? That's probably what you're looking for, and also you're getting a job in blockchain. Then there will be a Q&A session and conclusion. Throughout before starting, so now we'll start to talk about blockchain. So if you think that I'm going a little fast, you can comment in the live chat. You can comment in the chat box. So I'll try to slow down a bit. And if you think that I'm going very slow and taking a lot of explaining a lot of details, then you can ask me to speed it up. So Ashwita will let me know about it if you guys are commenting. So to start with, what is blockchain? So blockchain, very simply put in a layman language, is a chain of blocks. As you can see here, there are 3 blocks in this blockchain. This is a very simple and basic blockchain. So in blockchain, what happens is there are chain of blocks, and the first block in the blockchain has a previous hash as 0 address, which is called as a genesis block. So how the blocks are linked is every block has a value as previous hash, which is hash of the previous block. So hash is basically, you can say it as name of the blockchain, or block number, or a unique identifier of the blockchain. So every next block has a previous hash as the previous block. So you can see here the block 2 has previous hash as 3W8F, and it is the hash of the first block 1. Similarly, block 3 will point to block 2, its previous block's hash. And this is a new block which is not yet mined in the blockchain. So it is not linked to the blockchain yet. So it has transactions which are not confirmed yet. It is called mempool, which is memory pool. So whenever you send a transaction, it's not confirmed. It's sent to a memory pool, and after that a miner picks it up. A miner is basically who solves a complex problem, and then adds the block to the blockchain. And to see this in real, how it works in real world, I'll show you an example. So blockchain is basically making use of hash in almost everything. So first we'll start with very basic, which what is a hash. So hash is a unique hash of data. If you write Mehul here, it will turn into a different hash. If I add a space, the hash will turn different. However, if I have five characters in it. The hash is of this length. Even if I have 1000 characters in this, the hash will be of same length. The length of the hash will not change. However, the hash will change, but the length will always stay the same. The blockchain makes use of hash in calculating block hash, in calculating transaction hash, in almost each and everything. So, if you get what hash is, we can move to what a block is. The block always has a number, an optional nonce. Nonce is basically a number which is used once. So in a blockchain, if let's say 10th block has a nonce of 84, then no other block in the same blockchain can have nonce as 84. I'll show you with the example and why nonce is used. Basically, if a block has data, a block hash has a and a block number, why do we need nonce? Now I'll tell you why do we need nonce. So this every blockchain has a problem. You might have heard about proof of work, proof of stake blockchain. If you haven't, don't worry, I'll tell you what is it. So you must have heard about Bitcoin and Ethereum. So what they do is they have a blockchain problem. So in this blockchain, there is a problem that whenever we calculate a hash, the hash should start with four zeros. If the hash does not start with four zeros, then it's not a valid block. So when the block number is 1 and the nonce is this 72,608 and there's no data, the hash is this, which is starting with 0000, and it's fine because that's the blockchain problem. What if I add, let's say, Veset here? So when these three values are sent into a hash function, the hash turns out to be this, but this is not a valid hash. So that's when what miner will do is it will start from 0, 1, 2, 3, 4 by passing it as nonce, and it will pass it into the hashing function, and the hashing function will return the hash. It will do this calculation for all the integers until it returns the hash which starts with four zeros. So it started from 0, and at 80,649 nonce, the hash was returned as 0000. So this is called as solving a blockchain problem, and that's what miners do basically to add a block into the blockchain. Uh, so this was the example of a block. Then moving on to a blockchain. So this is a chain of blocks. You might have heard about blockchains are immutable. So if you change anything here, you cannot basically change a transaction. We'll move to transaction in a minute, but this is how blockchain looks like. So its previous hash is 00. That means this is the first block of the blockchain. It's the Genesis block. And this hash will be similar to the previous block's hash. So this is pointing to this block's hash. Block 3's previous hash will point to block 2's hash, and similarly for till the last block. And if we add block 6 here, so block 6 previous hash will be this, and block 6 own hash will be something else depending on the nonce. So this is basically what blockchain looks like. And so how do we know that someone? So let's say I change something here. Let's say I write Veset here, and I mine it again. So then the blockchain was of 5 blocks, but then now it says only there are 2 blocks. Why? Because the hash of this is changed, and this hash is not pointing. This hash is still pointing to it because we have not mined it, because this hash is not starting with 0. If we mine this block again, the hash will change, and we have to again change this hash because now this hash is different. So this hash is different, and this hash is different, and it's not starting with 4 zeros. So we have to mine this block as well, because this is not, whatever turns red, is not a valid block. So that's why we have to mine that block again, and then we have to mine this block again. So I changed something at block 2, and I mined all of these again. The hashes did change, and the nonce also changed. So how can we say that no one can change the blockchain? And to answer that is this. So blockchain is distributed between different peers. So this is peer A. Let's say this is Mehul. Let's say this is Sunny, and let's say this is Johnny. So we are 3 people in a blockchain. We are 3 miners, and we will all have the same copy of the blockchain. So see, they all have the same copy of the blockchain. The hashes will match, block numbers will match, everything will match, even the nonce will match, because this is the same blockchain. So let's say I want to do some changes. I want to make some changes in the blockchain. I want to write that this is Mehul. I'll mine this. I'll mine this. So I also have a valid blockchain. But so there's something called as consensus, which is which blockchain to be selected in terms of different blockchains. So let's say I have this blockchain, which is the end hash is 4621 and 590, but this blockchain ends with uh, a hash which ends with 217C, and this one also ends with 217C. So two people have the same blockchain, but one person has a different blockchain. That means there's something wrong with this person. So uh, it will go with the blockchain which is with most of the people. So in consensus of Ethereum, it says 51% rule. If 51% people have the same blockchain, that is called as a valid blockchain. And there's also one more rule, which is longest blockchain. So whoever has the longest blockchain is has the valid blockchain, because when I change something here, I need to mine this again. I need to then It's taking some time because it's probably not finding a valid nonce. So I have to mine these four blocks again, block number 2, 3, 4, 5. I have to mine all of these blocks. While I'm mining these four blocks again, 2, 3, 4, 5, some other miner is mining four more blocks, which is 6, 7, 8, 9. So that one will have the longest blockchain, and that will be selected as a valid blockchain. So this was about blockchain. Again, this is how transactions are recorded in a blockchain. So again, it has a amount from and to. So if I want to say I want to hack this blockchain and I want that everybody has transferred to me, I write Mehul here, I write Mehul here, I write Mehul here. So that I have a lot of money. But then while I'm mining this block and I'm mining the next block, someone else is mining sixth and seventh block, which will have the longest copy of the blockchain. So my blockchain is going to be invalidated and that will be deleted. So then I cannot benefit it, and I cannot change anything what has been mined. That is how blockchains are immutable, and we cannot change what is mined. So this was basic about blockchain. Now moving forward, some advantages and disadvantages of blockchain. In blockchain, there's no central authority. So uh, it's run by people, it's used by people, and it's running for the people. So there's no one who is controlling it centrally. There is a little bit of control in Ethereum, because there was a hack which happened in 2015 that has drained about $80 million, and that could have taken the whole Ethereum ecosystem down. So that's when Vitalik Buterin, the founder of Ethereum, came ahead and forked the blockchain, made another copy, and made a separate blockchain. So to prevent situations like these and to save the network and to save the blockchain, there is some central authority which is controlling it. So this was about blockchain. Hey, sorry, I was disconnected. Okay, where was I? What was the last thing you heard?
Mehul, you were explaining about the Bitcoin part.
Okay. Okay, I'll share my screen again.
The 80-meter hack.
Yeah. So then Vitalik came ahead and actually forked the blockchain into two different blockchains so that the money of people and the network is saved. Now, there are disadvantages as well of no central authority. So then if you put something bad on YouTube, let's say an animal abuse or something politically incorrect or something which promotes terrorism, YouTube will go ahead and remove it. But if you don't have any central authority and there's a decentralized YouTube, then people can put anything on it and nobody will be able to remove it. So that can lead to some bad purposes. Then it's decentralized and distributed, so it's not owned by anyone, and it's the copy of the blockchain, and all the transactions are with everyone, and anybody can go and check and validate the transaction. Then it's immutable. That's what I showed you now. The data once done and mined cannot be changed. Then it's transparent and traceable. There's With every blockchain there's a block explorer. So for Ethereum there is Etherscan. So if we go here, we can see which is the latest block mined. We can open the block. We can see who is the miner. We can see what is the block reward, and we can see the transactions as well. So that's how this is the block's detail. And if you want to see, these are the latest transactions. So if you open any transaction, this is the transaction hash. Hash is already something I've showed. Which block it's mined, who is the caller and who is the callee, and what happened in the transaction can be seen from here. So that's how open and transparent the blockchain is. And every blockchain has its own block explorer so that you can go ahead and see anything you want. Then it's secure. Security I've also shown that you cannot change any data. It's fast. So let's say you want to do a money transfer to a foreign account. um, let's say you want to transfer from INR to USD. It will take minimum 3 days for your transfer to go through. But in blockchain, it doesn't take 3 days. And in that also, if you transfer huge sums from bank account, someone might block your payment and someone might block your account and question you where this money came from. So in blockchain it doesn't happen. So in Bitcoin every new block is mined in 10 minutes. In Ethereum every new block is mined within 10 to 15 seconds. So whenever you do a transaction, whenever you send money to someone using Ethereum, your transaction will go through within 15 seconds, and it can be anywhere in the world to anyone you want and of any amount you want. That's the benefit and the beauty of blockchain. It's cheap for users. So you pay for transaction fees. You pay a lot of transaction fees on to your banks, but here you don't pay a separate transaction fees. You only pay for gas fees. So you don't pay anything to the bank. You don't pay anything to the intermediaries. You only pay gas fees for the miner who is working on securing your transaction, who is working on calculating the block problem and mining that transaction, validating that transaction basically, and nothing else you pay for. Now we talk about disadvantages. So interoperability is very difficult in blockchain. Now we have come up with bridges, but that's not very secure. So let's say Ethereum blockchain cannot easily talk to Bitcoin blockchain or Solana blockchain. So these three are different, running on a different world. Talking between communication between these is very difficult. Immutable is also a disadvantage. We write smart contracts on Ethereum blockchain, and you also know that there are versions of applications. So once you write a code, there can be bugs, there can be updates, or anything which you need to change. So in Web 2, you can simply deploy a new version. But in as blockchains are immutable, once a code is deployed you can never change it. Now we have come up with upgradable smart contracts, but that's still complex. You cannot basically change the code what is already deployed, but there are some ways that we have figured it out, and we have came about it. We have fixed basically those problems. So it's inefficiency, which is proof of work wastage. So I told you that whenever the new transactions are sent in the transaction pool, everybody starts finding the hash, which starts with 40. This is just an example. Every blockchain has a different problem. So everybody starts to use that hash function with different nonce. So only one miner will get the hash first, and whoever gets the first will be able to mine the block. But there are tens and thousands of other people who are also trying to find the block hash, which starts with 4 zeros. But if they are not first, if they are second or anyone after second, their energy and their time and their resources are wasted, what they have inputted in calculating the hash. So only one person gets the reward. Then there's storage limitation. Bitcoin is only for transactions. Ethereum has smart contracts, but you cannot store a lot of images. You cannot even store images. You cannot store videos in blockchain. You can only store transaction data, code, and interactions. Then integration is difficult, so it's easy to interact with a centralized application. You can have it on your phone, on your app, on your laptop. But if you want to interact with a blockchain, you need a blockchain browser, which is MetaMask. It's also a wallet, so you can use that to interact with blockchain. And its implementation cost is very high. So even if you so in social media, you see a lot of things. But let's say if you like or if you comment on any post, you have to pay for gas. That's what happens in blockchain. So in blockchain, if you need to modify the state of the blockchain, you need to do anything with the blockchain, you have to pay for the gas. So if a social media is built on blockchain, then you need to pay for every like, and you have to pay for every comment you do, because that is getting stored in the blockchain. These are some of the disadvantages. You can use any of these to research on, and you can see that how you can make it better. But I have some separate topic as well in the end. So talking about, are we too late? I think not very late, but somewhat late. You cannot stay back and you can think that no, we have a lot of time. We are actually a little late, because there are almost 3 million blockchain developers now throughout the globe, and there are over 200 million Web 2 developers throughout the world. So we are not very late, but we are still a little late. So let's get started and study about it. So going through history a little bit, in 2009, first Bitcoin block was mined. Bitcoin was the first blockchain. Ethereum was second. In 2015, Ethereum was launched. And in 2021, that's last year, we got NFTs, Metaverse. Metaverse is basically a virtual world. In 2025, we are expected to grow at a 65% rate. And in 2030, we will be completely transitioning to Metaverse. So Facebook has changed their name from Facebook to Meta, because they are completely going bullish on Metaverse. So Metaverse is basically a virtual world. So you can meet people virtually while sitting at your home. Even with Instagram, we are very much interested in people's virtual life. But then Metaverse has enabled us to have virtual meetings, virtual gatherings, and everything. So what are the prerequisites if you want to get into it? So you need to have exposure to at least one programming language, which is C++, Java, JavaScript, Python. Then you need to have understanding of object oriented programming concepts. You should love challenges, basically. It's challenging actually to learn a new technology, to learn a new thing. Just give me a minute. Okay. Sorry, actually, I'm not in Mumbai. I'm not in my hometown. I'm out. I had to travel to Delhi for some urgency. Okay, sorry. Continuing. Um, You should love challenges. Learning a new technology is very challenging, and you will face a lot of hurdles and challenges when you are learning a new technology. So you should be ready to be a part of a growing community. So the community is very small as compared to Web2 developers, but the community is very helpful, and there are crazy people that you will come across with. Then you need to be ready for a lot of learning, because it's completely different. It's completely different as compared to what you have seen in Web2. Web3 is completely different. A lot of trials and errors. So as the community is new, and if you're trying to implement something which is not being already implemented, so you'll not get any help, and you need to try different things, try and try till it works. So getting into blockchain is a simple 3-step process. First, you need to know, and you need to invest at least 300 hours. It can vary from person to person. You may be able to complete it in 100 hour or maybe 500 hours, but then it's upon you how much are you willing to learn and how fast are you willing to learn. So these are some resources. On YouTube, you can go to Whiteboard Crypto, Dab University, Eat the Blocks, Paul Barron Network. These are the people who are actually transitioning Web2 developers to Web3 developers, and they talk about blockchain. So Whiteboard Crypto is for basic users, and they actually they actually simplify all the concepts for you, and they explain it in layman language. So if you don't want to go to YouTube and watch videos, you want to search on the web, you want to read, then you can go to Medium. Medium.com is a blog site. Then Ethereum.stack exchange. It's just like Stack Overflow for Web3 developers. Then there's freecodecamp.org. This is also related to Solidity and blockchain coding. Then there's Dab University. So Dab University is also for blockchain developers. You can use these resources to know. Then you have to learn. Now I'll say you learn. I'll say that go on these resources and learn. But what to learn? So learn Ethereum, how Ethereum works, what is block, what is mining, what is gas. Learn about these things. And preferred is Ethereum because it's not just Ethereum, but a lot of people has actually used the code of Ethereum and made their own different blockchains, which is called as EVM compatible blockchain. So it works exactly like Ethereum, but on a different network. So you might have heard about Binance, Avalanche, Polygon, Arbitrum, Optimism. These are some of the blockchains which are not Ethereum, but then they are just like Ethereum. So if you know Ethereum, that means you know these networks as well. And if Ethereum uses Solidity, Solidity is a programming language for writing smart contracts. That's what I do day in day out. So if you know Solidity, you can not just code for Ethereum. You can also code for Binance Smart Chain and all of the other EVM compatible blockchains. So if you want to get started, there are a lot of opportunities for Ethereum and Solidity. But yeah, for some reason, if you want to go to the specific niche category, then you can learn Bitcoin, Solana, EOS, Tron. These are some of the different blockchains which are not Ethereum blockchain and not very in demand. So then Solidity is a programming language for Ethereum, but alternatively you can learn Viper. Viper is just like Python, and Solidity is more like JavaScript and C++. And Rust is a different programming language which is used for writing smart contracts on Solana. Then some of the development frameworks which are being used. So Hardhat is widely used. It's very good for smart contract development and decentralized apps development. Then we use Brownie, but that's a specific niche that uses Brownie. Then, but if you want to go on a basic and beginner level, you can start with Remix. It's a it's a web based it's a web based development it's a web based development. What do we say? Uh, Development tool basically. And there's Truffle. So Truffle you have to install in your machine, but Remix you can access from your browser, like this. Remix.ethereum.org. So you can access Remix through your web browser, and you can write smart contracts You can write Solidity smart contracts. You can deploy it on the Remix blockchain, and you can interact it with it. It takes some time. We'll come back here in some time. So the preferred operating system to work on is Linux or Mac, but you can also use Windows. That doesn't matter much. It's better if you use Linux or Mac. Then Chrome is preferred. Brave is also good. Then preferred is MetaMask. It's widely used and it's available on your. It sits as a browser extension. It can be installed on your browser. You can have it in your phone. Then alternatives are Binance Wallet, Coinbase, Phantom. And you can learn on YouTube, or you can do graduation in blockchain. There are graduation programs. They have they charge you 1.5 lakhs and they give you a graduate degree. You can also have courses on Coursera, Udemy, but I have learned through YouTube. I have not paid a single penny to learn anything about blockchain. Everything is free and open on YouTube. Also, if you want to learn about a specific protocol or a specific decentralized application, like Uniswap, which is the most popular decentralized application. So you can read their official docs. You can check their GitHub repos. Everything is open source. Yellow paper, white paper. White paper is basically in which they propose what they want to do, and yellow paper is more technical version of that. And again, they have YouTube channels as well to explain what they're doing. Alternatively, you can read books, Mastering Bitcoin, Mastering Ethereum. That will teach you a lot of stuff about these things. Then you have to implement token standards, ERC20. These are some of the most famous token standards, ERC20, then 721, 1155. You need to know what oracles are, then implement upgradable smart contracts, then also code a normal smart contract, deploy it on testnet. So Ethereum has its own testnet, which is Goerli or Rinkeby. So what happens is, if you want to do a runtime testing, you want to see how it performs on the blockchain. You don't want to spend gas on every transaction, on every deployment. So they have their own test nets. There you can get test ether from their faucets. And if anything of this concerns you, please write it and I'll explain it in the Q&A session. So you can get test Ethereum from their faucet, and you can use it for deploying and runtime testing. Then create and deploy ERC tokens. So these are standards. You can deploy these contracts and you can play around with it and interact with DeFi protocol. Basically, to start with Uniswap. So you can write your own smart contracts that interacts with other smart contracts and do things for you. So let's say I want to achieve a task. I want to do something, but I don't want to write code for that. So there's Uniswap, who has written the code for swapping two assets, or maybe exchange. You can, in normal terms, exchange. So I don't have to take care how the exchange works. I just need to take care how to get assets from the user, how to send it to Uniswap, and how to get the other asset from Uniswap. That's it, and that's very simple. Then what are the research opportunities? So blockchain is very fast growing and is technically very strong, but still we are lagging on some things. There are things that we still don't have solutions for. So there is one of those things is insurance. So first of all, I want to tell you that which are the things that we have found solution for. So blockchains cannot talk to normal web 2 APIs. So someone implemented chainlink. Chainlink gives you oracles, and with by using oracles you can call any API and get data from that. Before chainlink it was not possible. So imagine you are working on blockchain and you cannot call any API. So that becomes very difficult. That used to get very difficult. Now it's there. So then there was hyperledger. So what happens is blockchain is open for everyone. But let's say if you want to develop an e-commerce site, and in that your supplier is also there, your customer is also there, your manufacturer's address is also there. So manufacturer is selling it to the supplier for 50 rupees, and the seller is selling it to you for 200 rupees. So in that way, what you can do is you can directly contact the manufacturer and get it for 50 rupees, or you can question your seller or supplier that why are you taking 150 rupees. So for that reason, Hyperledger came into existence. So Hyperledger is basically consortium blockchain, wherein some part of the blockchain can be hidden from other users and other part can be visible to every user. So a customized blockchain. Then there's flash loan. So initially, how loan used to work is, if you want to have a loan, if you want to take a loan, people will judge you on your ethnicity, on your nature, on your behavior, where do you stay, how much people know you. Then after that, credit system came into existence. People check your CIBIL score and then give you a loan. But in decentralized world, you just need internet and laptop and no verification. So people can take loan and they will not return back. So that's why flash loan came into existence. So flash loan is a loan for very small period. You can borrow millions of dollars, but you have to return it in the same transaction. So you have to write a code for that, which borrows millions of dollars, does something with it, probably make some money with it, and then return back the money by the end of the transaction. And if you fail to return the money, the transaction will fail, so that nobody can run away with the money. And then there's compound finance. So for that, it is also for lending and borrowing. So you lend, let's say ether, and you can borrow 80% worth of any other assets. So that's again one part of the one solution for borrowing. Then we were facing a problem of high gas cost. So then people implemented layer 2 or parallel chains, which run their own network, but then they use the security of Ethereum. So they take 15 transactions, 20 transactions, and they combine it in one hash, and they send it on the L1, which is Ethereum layer 1. So that's how they achieve security and they achieve scalability. Then so every wallet is owned by a single person. But what if we don't trust a single person? So then Gnosis wallet came into existence. Gnosis wallet is basically, if you cannot sign a transaction or you cannot do anything if there are at least 3 people or 5 people agreeing to that transaction. So that's more decentralized, because one person can go corrupt easily, but if there are 3 to 5 people, the chances are very less. So now there are some problems which we haven't found solution yet. So insurance. Let's say I buy an insurance, a decentralized insurance for my crops, and I say that it rained and my crops got spoiled. There's no one to verify or validate. Just a minute.
ऐसे नहीं जो से इधर आके मैंने
Okay. So if I say that my crops got spoiled, and my crops got spoiled, and it rained, but no one is there to verify whether it actually rained or not. This is one of the problem. I can lie and get insurance money. So social networks is another problem. So let's say you want to pay for every like or comment you do. uh, how can you make it more optimized, and how can people pay less for these things? Then there's security is another concern. So people are actually, there are a lot of hacks going on. So you can research how you can implement security, because you don't know who is interacting with your decentralized application. You don't know what are the intentions of that person. In real world, if you want to sign up for Binance, or if you want to trade on NSE or BSE or any exchange like Zerodha, there's a KYC process. They take your Aadhaar, PAN, and biometric authentication and whatnot. But in decentralized world, there's nothing like that. So security is another concern. Then we have not yet achieved AI, artificial intelligence, using blockchain. So you can research about that. Then awareness is a very big problem. A lot of people know about blockchain, but they don't know how to interact or make use of blockchain. Then next point is verifying humanness. So as I told you that there's no KYC process yet. So if you want to verify whether that person is a human or a bot who is doing the transactions, so that is something which is still pending. Then what are the intentions of the person who is sending a transaction or who is interacting with a decentralized application? So intentions are basically a little hard, but then it's a good topic for research. Then making games on blockchain. So there are some games already, but those are very simple games like betting on something or small, very basic things. But these are not high-end graphic intensive games. So you can research how we can make use of blockchain to play games like PUBG or to play games like Temple Run or something like that. I don't play much games, so I don't know. But these are some of the topics which you can consider for research. I think this is the last thing. Yeah, career options. So you can be a blockchain developer. You can write smart contracts for Ethereum blockchain. You can be auditor, which is basically checking whether the code is proper or not, auditing the code. Then you can become blockchain core developer, which is not developing on Ethereum but developing Ethereum. So developing the blockchain itself. Then there's blockchain architect, which is checking which are the things we should use. So if you want to develop an application, so there are multiple things, multiple options to achieve a single thing. That's what architecture covers. So which alternative is best for clients' requirements. So that's architect. Which blockchain is best suited? Do they need more security or do they need more scalability? So then there's Web3 developer, which is comfortable with Web3 JS library, which enables front end interacting with blockchain smart contracts. Then there's front end developer. So everyone needs a front end developer if the back end is Web2 or Web3, but front end is same. So you can become a front end developer which knows a little bit about blockchain. Then blockchain QA. So quality is also required in blockchain decentralized applications. You can go into testing. Then a blockchain legal consultant. You cannot be a legal consultant now. So first you need to learn. You need to spend some years in this, and after that, once you gain a lot of knowledge, you can become a blockchain legal consultant as well. How to get your first job? These are some of the do's and don'ts. Chase knowledge, practice professionalism, confidence, solve problems with code, build a profile on LinkedIn, know the company and industry standards. So before appearing for any interview, know the company and industry standards. What are they paying? What's happening in the world, basically. Ask more than your expectation because they do salary negotiation. So if you want to, let's say, settle on 15 LPA, 15 lakhs per annum, ask for 18. So then they'll probably bring you down to 15. Um, know your interviewer. So whenever there's an interview scheduled, uh, check his profile on LinkedIn and know something about him so that you are able to build a rapport with him. Ask questions to your interviewer. That shows that you are confident. Whenever they ask you that, do you have a question for me? Never say that, no, I don't have any question. That shows that you are not very confident. You just want to end this interview. But ask something which is professional and relevant to what you are talking about. Do healthy negotiation. Don't come up like very needy or very greedy. Do healthy negotiation. Then be well groomed. uh, be the one they need. You need to have all the skills that they need, otherwise there's no fit and there's no job opportunity. Prove yourself in the interview. Sell yourself. Then these are some of the don'ts. Don't chase money. First chase knowledge, then money will come along. Don't be casual. Don't be at a noisy place while interview. This is not my place, actually. I'm not at my hometown, at my usual place. I'm somewhere else. That's due to some urgency. So don't have a poor connectivity while interviews. So that's about it for the session. Now let's move on to questions. Ashwita, are you there?
Yes, Mehul.
So
So
if you
thank you
have
so
any
much.
questions, yes.
Uh, yeah, thank you so much. It was indeed a knowledgeable and interesting session on this fast-growing technology called blockchain. So as we are
Thank you.
done with the topic, let's move towards the questions that our viewers have for you.
And again, I'm sorry for the background noise.
No, no, not at all an issue. Okay,
Are
so we have our
there any
first
comments?
question.
Yeah.
Yes, yes. We have our first question. On what basis the monetary rate for mining is determined?
Okay, so it depends on the network congestion. So let's say if there are a lot of transactions which are there in the memory pool, so your transaction, so there are three. There's gas tracker first of all for Ethereum. I can show you that. My screen is still visible, I think, right?
Yes, it is.
So there's Ethereum gas tracker for Ethereum network. So this is the gas price for low, then average, and high. So obviously you want to save money on your gas, so you'll send a transaction with 8 way. But let's say a miner can take ten transactions in a block, and there are 20 transactions. So it will take the 10 with high gas so that it benefits him. Otherwise, if there are 10 transactions which can be taken and there are only 5 transactions, then obviously your transaction will be picked. So the more the transactions, the more the congestion, the higher the gas. I think it clears your doubt, Chinmay.
Okay. We have a next question. As you explained about the transactions of blockchain technology, can you elaborate a bit about blockchain wallets?
Yes. So blockchain wallet, MetaMask is the most famous blockchain wallet. So how a wallet performs is like I'll show you quickly. So this is MetaMask. It comes with a Chrome extension. This is the logo of MetaMask. So MetaMask is a hierarchically deterministic wallet. So it gives you a 12-word mnemonic, that's 12 random words, and by using those 12 words you get 10 accounts, and 10 accounts have their own private key and have their own public key. So let's say whenever you are sending a transaction, you also your private key is used to send that transaction to the blockchain, and that's so otherwise anyone will be able to send transaction using the public key. So a public key a public key is different and a private key is different. So you can your private key is basically used to even sign if you don't want to pay for the gas. There is something called as meta transactions. So at that time your private key is used, you just sign the transaction and someone else pays for the gas. So and if you want to see how wallet addresses look like, I cannot show you my wallet address, but so let's say we take any transaction. So this is a wallet address. This is how wallet address looks like. This is the public key of the wallet, and this is his transactions. What are the transactions which this wallet has done? This is the token transactions. He has not done any token transactions. So that's what. So if I USDT, so USDT is another stable coin, very very famous. If we see the holders, so let's say this is a holder. It has 845,000 USDT. So this is a contract actually, and contract and account addresses looks the same. So this is a contract address which holds $845,000 worth of USDT. That's all. Next question.
Okay. So our next question is, can you suggest some courses for the practical and theory?
Yes. So if you want to go for the free version, I would recommend that you go for the free version. You can search blockchain development course, and I recommend first this guy. I've also told free code camp org in my session. So this is a 16 this is a 31 hour long course. There's one more course of his. Yeah, this is 16 hours long course, solidity blockchain and smart contract course, beginner to expert. And he's also shown Python because he has used Brownie. So this is code eater, and this is free code camp. This person works for Chainlink. So you can watch any one of these to start with. If you have less time, I would recommend you go with this one. This is a 6 hour long course. It's titled as blockchain full course, 6 hours. I'll send the link in the session.
Okay.
Yes.
Our next question is I am a fresher to blockchain and I found difficulties in finding a job for a fresher. They are hiring freshers for less than the package I was getting in my previous organization. Should I join?
I don't think we can discuss the specifics here, but so it's about the organization. If they want to save money and they want to hire for cheap, they'll try to negotiate. But it's on you that if you want to settle or not. I know a friend of mine who got settled for a little lesser amount just because she wanted to get into blockchain. And there are other people as well who for whom knowledge matters more and money comes after that, so it's on you to decide. But I think don't go for that organization. Try for another opportunity, because a valid and a genuine organization will give you hike, at least 30% hike on your last round package, uh, whatever your profile was. Even if you're switching from web 2 to web 3, they should give you a hike, and it's not difficult to get it.
Okay. So we have one more question. So, which is the most famous and widely used application of blockchain that I should start learning to get a job?
Um, so if you so the most widely used, widely I would say used application is Uniswap. So whenever you talk about getting into blockchain, decentralized finance is something which blockchain has helped a lot, and Uniswap is the first and the most widely used DeFi application. So yeah, learn Uniswap.
Okay. So I think that was the last question.
Yes.
Okay.
Okay. Okay,
Yeah.
then conclusion. So I was able to tell you a little basics about blockchain, and I've given some resources here. I'll share the PPT, and you can get the data which is here in this one. So I'll share
Okay.
the PPT. You can share it with the people. And
Yes.
thank you for being with me. Thank you for listening.
We had a great and engaging, informative session. As we come towards the end of the session, I hope we all have learned a lot from this session. We would firstly like to thank Mr. Mehul Tateja for taking his precious time to join us today and enlighten us on this topic. Last but not the least, we would like to thank all our viewers for patiently listening to the session and for such a great response and such brilliant questions. Also, do not forget to fill out the feedback form. The link has been shared. That brings us to the end of the session. Thank you, Mr. Mehul. Thank you, everyone. Have a great day ahead.
Thank you. Thank you.